Okay, in the last little bit here, we're going to expand and collect our like terms in the numerator here. So this could take a moment. Binos, we're going to do FOIL here. X times x, x squared. Keep it inside the bracket. X times 4, that's 4x. 2 times x, that's 2x. 2 times 4, that is 8. And we can collect our like terms inside the bracket here. 4x plus 2x, that's 6x, isn't it? Plus 6x. Alright, we got subtraction sign, and this is key. A lot of people miss this. Subtraction sign just to the left of a bracket. So we're going to put another bracket here. And we expand x times x, that's x squared. X times negative 2, that's negative 2x, plus 5x, that's positive 3x. And 5 times negative 2, that's negative 10. All over x minus 2 times x plus 2. Now we can get rid of the brackets. If you recall, I'll set it up here. X minus 2, x plus 2 in the denominator. It's implied there's a 1 in front here. When it's implied there's a positive 1, we can eliminate the brackets. We'll end up with x squared plus 6x plus 8. But there's a subtraction sign outside these brackets. So when it's like a negative 1 is here. Negative 1 times x squared, that's negative x squared. Negative 1 times 3x, that's negative 3x. And negative 1 times negative 10, that's positive 10. Collect your like terms in the numerator. X squared times minus x squared, they cancel each other out. There's no more x squareds. 6x minus 3x, that's 3x. And 8 plus 10, that's 18. So what will end up in the top is, I believe it is, 3x plus 18. That's what we have in the numerator. Okay, when we expand and collect our like terms. Now the last part here, you're almost done here. We would see if we could factor the numerator. And we can. 3x plus 18. We can take out a greatest common factor. You take a 3 out of 3x, you got x. And you take a 3 out of 18, you've got, what do you got there? 6. And now you would check, hey, is there anything common top and bottom that I can cancel out? Not in this one. In others you may, but not in this one. So that's it. That's as far as we can go with this. It was a lot of work, and you can see how it got larger before it got smaller. Feel free to review this video, this part of the video, and check your notes here. Okay? We can do a couple examples now. Okay, I chose this one. 1 over x squared minus 36 minus 1 over 6x minus x squared. I chose this one for a reason, to try to remember. This one looks like it's written backwards, so we're going to need to straighten this out a bit in order for it to work first. If you have 1 over 7 minus 1 over negative 6, two negatives, we can change that to addition, right? It's kind of the same idea here. We can rearrange these terms so it looks like something we've seen in the past. So we have negative x squared plus 6x. Now, we can take out a factor of 1 here. If I take out a factor of negative 1 out of x squared, I get x squared. If I take a negative 1 out of 6x, I end up with negative 6x. So, negative negative 1 outside x squared minus 6x. And like we had two negatives here, negative, negative 1, we can change that to addition here. We'll just straighten it out a bit. Now that's straightened out, we can approach this. What was the first thing we need to do? In any of these, factor your numerators and denominators. 1 over x squared, we can factor that. X plus 6, x minus 6. Let's put that difference of squares factors out to. Plus, now that we got the addition sign here, 1 over x squared minus, we can take out the greatest common factor of x. And we end up with x minus 6. What are our non-permissibles now? Our non-permissible values. X cannot equal, from here, negative 6, from here, positive 6, and from this single x. If I was to put a 0 into the x, I'd end up with a 0 here. So it can't equal 0, negative 6, or positive 6. Now the next thing we'll find is our lowest common denominator. The lowest common denominator is a combination, remember, of both denominators. We have an x in one of them. We have an x minus 6 that's common to both, but we only need to write it down once. And we have an x plus 6. There's our lowest common denominator. So we're going to rewrite each of these expressions as equivalent expressions, but to have the LCD x plus 6, x minus 6, x times x plus 6 times x minus 6 in the denominator. Well, what's missing from this denominator that we have down here? There's a 1 in the top of both of them. We're missing an x, so it's like we multiplied top and bottom by x here. X times that, we have this. 1 times x is just x. And what's missing from this denominator that we have down here? Oh, we're missing the x plus 6. We have it here, we don't have it here. So it's like we're multiplying top and bottom by x plus 6. And 1 times x plus 6 is just x plus 6. Now that we have equivalent fractions, equivalent expressions with the same denominator, we can add the numerators, x plus 6, over one denominator, over the LCD. Can the numerator be combined any further? Yeah. If we eliminate the brackets, we've got x plus x is 2x, plus 6 all over. Oh yeah, x plus 6, x times x plus 6, and x minus 6. Can we factor the numerator? Sure we can. We can take a common factor 2 out. Can anything be canceled out top and bottom here? Nope, that's as far as it goes. That's as far as it goes.